Hello everyone. In this video, we are going to talk about the single point cutting tool, an important tool used in the machining domain. It helps with tasks like turning, facing, making flat surfaces on machines like lathe, wood lathe, shaper, and planer machine. The single point cutting tool is designed with a sharp point and a shank, making it easy and cost effective to manufacture. It can be made from different materials like the high carbon steel, high speed steel, ceramic, diamonds, etc. Understanding the parts is important. See, it consists of parts like the nose radius, the flank, the face, the shank, the base heel, the nose, and the cutting edge. Now let us talk about each of these parts of the single point cutting tool in detail. The very first part is the nose radius. See, the nose radius is a rounded curvature at the tip of the tool's nose. It serves multiple purposes such as enhancing tool life by distributing the cutting forces, reducing the likelihood of chipping, improving the surface finish of the workpiece overall. Second, we have the flank. Now the flank refers to the surface below and adjacent to the cutting edge. It plays a crucial role in guiding the chip flow during the entire cutting process, ensuring efficient chip evacuation and preventing chip jamming. Third, we have the face. The face is a surface on which the chips slide as they are being removed from the workpiece, preventing built-up edges and ensuring a clean surface finish. Fourth, we have the shank. The shank is the main body of the tool, acting as a support and holder for the entire tool. It is clamped into the tool holder, securing the cutting tools in a place during machining operations. Fifth, we have the base heel. This is located at the intersection of the flank and the base of the tool. The heel is a curved portion at the bottom of the tool. It provides stability to the cutting edge and contributes to the tool's overall strength. Sixth, we have the nose. Now the nose is the point where the side cutting edge and the end cutting edge intersect. It determines the tool's geometry and influences as to the type of cut the tool is able to make. A well-defined nose is critical for achieving a precise and accurate machining result. Lastly, we have the cutting edges. Now the cutting edges is the sharp edge on the face of the tool responsible for the material removal from the workpiece. It consists of two primary edges. One is the side cutting edge, that is also called as the major cutting edge. Second is the end cutting edge, that is also referred to as the minor cutting edge. Now both of these cutting edges contribute to the overall cutting performance of the tool. Now understanding the different parts of the single point cutting tool is essential for optimizing its performance in the machining process. Each component plays a significant role in determining the tool's cutting abilities, efficiency, and overall machining quality. By carefully considering the design and characteristics of these parts, engineers can select and utilize the ideal cutting tool for specific applications, achieving precise and productive machining results. Now let us talk about the geometry of the single point cutting tool more in detail by talking about its angles. First, we talk about the back rack angle. Now this is the angle between the tool face and a line parallel to the shank. This angle affects the cutting edge orientation. Next, we have the side rack angle. This is the angle between the tool face and a line parallel to the shank, but it is measured in a plane perpendicular to the shank. Now this angle affects the face flow. Third, we have the end relief angle. Now this angle is between the end flank and a line perpendicular to the shank. Now this angle helps to reduce rubbing and ensures smooth cutting. Fourth, we have the side relief angle. Now this is the angle between the side flank and the line perpendicular to the shank. It helps in preventing friction and rubbing during the cutting process. Fifth, we have the end cutting edge angle. Now this is the angle between the end cutting edge and a line perpendicular to the shank. This angle influences the tool's cutting efficiency. Lastly, we have the side cutting edge angle. Now this angle is between the side cutting edge and a shank. It affects the tool cutting action. Now that we understand the angles, let us talk about the advantages and disadvantages of this single point cutting tool. To begin with the advantages, the single point cutting tool is a versatile tool, precise and cost effective to manufacture. It works on materials like metal, wood, plastic very easily. But like the two sides of a coin, this tool also has its disadvantages. It may wear out faster, have a shorter life, a bit slower compared to other tools. In my conclusion, the single point cutting tool is a crucial part of machining process. By understanding its parts and angles, we can use it efficiently and more precisely for material removal process. It is an essential tool in modern manufacturing process, making products better and more reliable. Thank you everyone for watching. If you have any doubts, any questions, write to us in the comments below. Make sure to like and share the video and subscribe to our channel to keep yourself posted on more engineering and woodworking related content. We hope to see you soon. Goodbye.